All right, it's time to get into the nitty-gritty of limits here, dealing with solving them analytically. And analytically, easy for me to say, just basically means algebraically. I had to check if I spelled that correctly. So basically, we're going to have lots of different methods that we're going to try to be able to solve limits analytically. The first step, always is to try direct substitution. We'll see what that means here in a second. Beyond that, we can do some basic algebra maneuvers, trying to divide out factors. You'll see how that'll look. Rationalization, if you have square roots. And not yet, but there's another one called L'Hopital's rule that if all else fails, L'Hopital's rule can be used as well. But we won't get to that for some time here. So let's just jump right into it. Here's a limit. And we need to solve this limit analytically. And what I mean by that, with direct substitution being your first step, here's your number, plug it in. Just that simple. 2 squared minus 5 times 2, so 4 minus 10 is -6. You're done. That's it. Just that simple. Another one. Direct substitution, you should get 1 on top and -2 on the bottom, so -1/2, just to make it look a little cleaner. And even trig functions, yes. Sine of pi over 2. Well, sine of pi over 2, we can directly plug that in. Think of your unit circle. Pi over 2 is up here at the top. Sine is the y value, so that means that's an answer of 1. Pretty easy so far, right? Yeah, it gets a little more difficult than that for sure. So when you try to direct substitute in this, and this is what's going to happen probably 99 times out of 100, when you plug in, you get 9 minus 12 plus 3. So you get 0 on top, you plug in 3 on the bottom, you get 0 on the bottom. 0 over 0, is that, well, you can't divide by 0, right? Well, we'll adjust that thought process down the road. But basically, this idea of 0 over 0, this is called an indeterminate form. And what that means is we don't know what we're dealing with, because anything dividing by 0 is a really big number. 0 divided by anything is 0. Well, we don't know what that possibly could be. So that means that we, at the moment, don't know what this graph is approaching, what this limit is. We can adjust that, though, sometimes with some basic algebra. So in this problem, for example, I notice I can factor both the numerator and the denominator. So I'm going to do just that. My denominator is a difference of squares. My numerator will go to x minus 3 and x minus 1. And this is what's going to happen basically every time. Something should cancel. And it did. Good. So when that cancels, I'm left with just x minus 1 on top and x plus 3. Once something cancels, go back to step 1. What was the very first step we said? Direct substitution. So we're going to go now that we've canceled and plug back in this limit value of 3. So when I do that, I get 2 on top, 6 on the bottom, so I get an answer of 1 over 3. That's all we got to do. Same thing here. Plug in 0, pretty easy to see that we're going to get 0 over 0. So I need to try to rewrite this. Again, this is a case of something we can factor. Factor out an x on top to be left with x minus 4. Bottom, it just stays as 3x, but that's good because we now have an x on the top and bottom that can cancel out. Leaves us with the limit as x approaches 0 of x minus 4 over 3. Remember, keep that limit as x approaches 0 until you plug in 0, which we're doing right now. When I plug in 0, I get -4 on the top, I get 3 on the bottom. -4 over 3 is my limit value then. Here's a couple for you to try. See how you do. All right, hopefully you paused and gave this a try. You get 0 over 0 until you do your factoring here, and make sure you don't do what I just tried to do. I'm not plugged in x equals 2 yet, so I need to make sure I keep that limit as x approaches 2 written there. X minus 2, x plus 2 is how the top factors. Your denominator here, factors of 6 that add to 5 are 2 and 3. So I get both the negative here, and again, things should cancel. If you go through these problems and something doesn't cancel, you've probably made a factoring mistake. Just double check yourself because these should cancel basically every time. X plus 2, x minus 3. So when you plug in 2 now, because we can evaluate the limit now that this x minus 2 is canceled, we should get 4 on top and negative 1 on the bottom. So negative 4 is your answer. Number 2, when you try to factor, nothing cancels. Well, why does that happen? Did you remember step 1? What do you always do first? Plug in. What's 0 divided by negative 9? 0. Just that easy. Don't forget, plugging in first can possibly get you the answer. Last one down here, if I plug in 1 into this one, same exact thing. I get 2 on the top, I get 0 on the bottom. Well, this isn't something I can necessarily factor and cancel, right? I mean, it is something that can factor and cancel. If I had factored the top, I'd have x plus 1, x minus 1. I'd still have things canceling, and now I would get 1 over 0 when I plug in 1. 2 over 0, 1 over 0. What does this really mean? Well, we'll get more into detail later, but basically the idea here is that we didn't even need to factor and cancel. We could plug in immediately and get something divided by 0. It's not 0 over 0 like this one was. It's not an indeterminate form. We'll find out later that this is actually going to be an answer of infinity. But for right now, we know we can't divide by 0. This would look on an AP test, this would say the limit does not exist because we cannot divide by 0. So there you go. Make sure you plug in first, factor and cancel if you have to.